Hello everyone and welcome to the channel. So today we will be discussing about invertible matrices and basically learning how to find the inverse of a matrix. How to find the inverse of a matrix. Okay. So starting with the basics, let me just give you an example that if I have a number 2, so which number should I multiply with it so that I will get the resultant as 1. So it is a pretty basic answer which is 1 by 2. So this means that this is my multiplicative inverse. This is something we must have studied in 8th grade, isn't it? So, on a similar line, in matrices as well, we have this concept where I have two matrices A and B. These two are my matrices. So, if I get this relation anyhow, that if my AB and BA is equal to identity. Now, in matrices, the identity matrix plays the role of my 1. So, if I were to consider in terms of 2 cross 2, and if I were to consider in my 3 cross 3 order, this is my identity matrix. This is my 3 cross 3. So if I anyhow get this relation that if I get an A and B such that I get this relation, it means that the inverse of B, we just, this is the notation of how we write. Okay. So my B inverse is A, and on a similar basis, my A inverse will be B. Now, the main important point here which is to be noted is that now note what condition we need is we need AB must be equal to BA and that must be equal to my identity. Now just focus that when is my AB and BA both defined? Okay, when is my AB and BA both defined? If and only if it is a square matrix, isn't it? Why is it so? Because for example, if I consider my A matrix to be of the order 1 cross 3 and my B to be 1 cross 2, okay? Now just check whether my AB and BA is defined. Okay. For AB, we will just write the order side by side. So we just cancel out the common element and we get the resultant matrix as 1 cross 2. Now what about BA? BA again we will write the order side by side. Now just focus that this is not defined. Why? Because if you have watched through my previous lecture, this 2 is not equal to my 1. So after considering these scenarios, it is understood that my inverse is calculated in my square matrices. Inverse is calculated for square matrices. So now that we are clear with this conclusion that we are only dealing with square matrices, so that my AB and BA are defined. Now that is not the only condition we need. We want both of these values to be equal to my identity. Okay. So then only we say that the inverse of B is A and inverse of A is B. Okay. So what we can now just, we will just look through a few theorems based on this. So this is my first theorem, which means a uniqueness of inverse. So the statement says that if the inverse of a matrix, if it exists, why do we say if it exists? Because it is not necessary that my BA and AB both are defined, like in the above example I just showed you, that it is not necessary that both of these values might exist, that too equal to identity. So if it exists, it must be a unique value. Okay. So for this, let me assume that I have a matrix A. Okay. Now this matrix A has two inverses. Okay. It has inverses B and C. Now what does this mean as per definition? What does this as per my definition? That AB must be equal to BA, that too equal to identity, because this is what my definition is. Now this is with respect to B. Now with respect to C, again AC is equal to CA is equal to identity. Okay. So these two statements are just by my definition. Okay. There is nothing difficult about these two statements. Okay. Now if I were to consider my matrix B, how can I write this matrix B? I can write this matrix B as a product of B and identity. Now we know that if I multiply my identity with any matrix, my identity is like my 1 in real number. Okay, like 1 in my numbers, identity matrix plays the role on a similar basis, if I multiply my any matrix with it, it will just give me my matrix B. So in a similar way, if I write my matrix B, how can I write it? I can write it as a product of my matrix B and identity. Now just focus if I were to see my now if I will focus my identity is equal to CA and AC, right? So I will just substitute this value AC, and now using associativity as we study in as a kid, this is my BA. Now what is my BA? My BA is again identity. This is my IC, and we know that anything multiplied with identity, it will just give out to be the same matrix. Now you can see this shows that my B is equal to C. So we have just proved that even if my inverse exists, two inverses exist, it has to be unique anyhow. Now my next theorem says that if A and B are invertible matrix, it is given that these two matrices are invertible, then if I consider the product of them, that is AB inverse, it means it is nothing but my B inverse multiplied by my A inverse. Now how do we prove this is that B, since because we are given that A, B are invertible matrices, it means they are of the same order. I mean, in terms of, it will be a square matrix. Okay, it means my product AB is well defined. Okay, so if I write this AB and multiply with its inverse, it will give me my identity, isn't it? If I'm multiplying anything with its multiplicative inverse, it will give my identity, isn't it? Now just pre-multiply the above with A inverse. Now with pre-multiply, what we mean is we just multiply on the left hand side. Left hand side, what will it give me? This is A inverse, this is my AB, this is my AB inverse, which is equal to A inverse identity. Okay. Now I will just consider these two values. I will just write it with a different color. Using associativity, I will just focus on these two values. This is my A inverse A. This is my B, which is left out, and my AB inverse. And anything multiplied by identity gives me the matrix itself. Okay. Now, as this is I'm multiplying my matrix with its inverse, this will give me identity. This is my B. This is my AB inverse. This is my A inverse. Okay. Now, if I again pre-multiply with B inverse, now what will I get? Pre-multiply means we multiply it on the left side. So B inverse B. Now anything multiplied by identity gives the matrix itself. So I'm not writing I now. This is my AB inverse. This will give out to be B inverse multiplied by A inverse. Okay. Now this will be my identity multiplied by AB inverse, which is nothing but B inverse and A inverse. Okay. So hence we have proved that my AB inverse is nothing but B inverse and A inverse. Okay. So this was the theorem. Now in the coming sessions, we will just discuss one question based on how to find the inverse of a 2 cross 2 matrix and for a 3 cross 3 matrix. Then we will just conclude the this topic matrices. Thank you.